It was mostly blue, and when we assembled it, we had a hard time fitting the wheels, like the inner tubes inside the wheels, like the new big inner tubes inside. So one of the wheels had like a little bit of a wrinkle on the very last edge that we couldn't quite stretch over completely. Um, so assembly is part of the process. And I didn't even realize that. I just thought when you got a bicycle that you just like rode on a bicycle, but you actually had to put it together. So and assembling the bicycle takes time. So I put the wrong word in. Instead of saying assembled, that's like it already was assembled. You actually had to assemble it yourself. So now, not the whole thing. Like you didn't have to like actually build the like the inner side, like the inner workings of the gears and stuff like that. But you had to put all the pieces together though. So assembling the mountain bicycle would take 5 hours for Model A, and it would take 6 hours for Model B. And then after assembling the bicycle, you had to paint it. And I think that's probably the wrong order because you probably had to paint it first before putting it together, right? Probably. Because otherwise you might get like paint inside of the gears or something like that. But anyway, according to this, there's assembling and then painting. And it says it takes 2 hours to paint the first mountain bike and 3 hours to paint the second mountain bike. So basically what I'm writing down is just a repeat of what's in the problem online. And I copied one of the problems online down from my example. Each of you will have your own unique problem though. So, however, though, guess what? Once in a while, people get really lucky, and there's probably somebody in the room who has the same numbers as me. Do any of you have the same numbers as me? Wow. Sweet. Okay, so that you got so lucky. So I wonder if all your numbers are going to be the same or just some. And I printed this out like a week ago, so I had no idea. Are you the only one? Does anybody else have the same numbers, 5, 6, 2, 3? And your problem? You do too? Well, maybe it's the same for everybody. I don't know. But that's cool though. So now the rest of my problem says that the total weekly hours available in the assembly department. So imagine that you're running a store that sold bicycles and you had an assembly department. Assembly department. Who would like to run the assembly department in your store? Yeah, Mason could run it. So the assembly department, and now it says the paint department as well. Who would like to run the paint department? Cool. So the assembly department and the paint department only have 240 hours and 114 hours of time for each one. And they say respectively, which just means in the same order. So 240 hours of time in that department and 114 hours in that department. So that's how many hours of time you can work in those two departments, because that's how much the people can work. I guess there's like that many employees or something like that. Let me take a drink real quick.
What's in there?
It is actually yesterday. Have you ever had the Panera Sip Club?
No.
So I got one of the strawberry fresca things or whatever, and I poured that in like the first half of it, and then got ice water with like a tiny bit of lemonade on the second half. So it's like strawberry flavored lemon water.
I didn't know.
Make yourself an ice. Yeah, literally no sense.
Okay, so do you want? I'll let you pick. What letter do you want to use to represent how many Model A bicycles that you use? So should I just use the letter A to represent Model A? Okay, perfect. So the amount of time it takes to assemble the bicycles is equal to, I'll use a small letter A. The small letter A equals the number of bicycles that are Model A. Number of A bicycles or whatever. And I'll say small letter B represents the number of B bicycles. Does that make sense to you? So how do I calculate the time that it takes to assemble all the bicycles together? Well, there's that many bicycles of Model A. So it takes 5 hours for each one. So it's going to be 5 times the number A plus 6 times the number B. That's equal to the total assembly time. So basically 5 hours for each bicycle A plus 6 hours for each bicycle B equals the total assembly time. Now, actually, if you really worked hard, maybe you could spend less than 240 hours making bicycles, maybe. So we're going to say less than or equal to 240. Because why work hard if you already have your job done, right? So 5A plus 6B has to be less than or equal to 240 hours. And then the paint department. How many hours does it take to paint a bicycle model A? 2. So it's going to be 2 hours times the number of model A bicycles plus 3 hours times the number of model B bicycles. And that has to be less than or equal to 114 hours total. So there's those equations. And what other information does it give me? Okay. The profits. Okay, so the profit is $20 for model A and $15 for model B. So the total profit that you make. So they've already calculated the costs and said they've subtracted the costs already. But if you subtract the costs, the final result is the profits are, let me say profit, Profit. Here we are. The profit is $20 for each model A and $15 for each model B. So every time you sell a model A bicycle, you make $20 of profit. Every time you sell a model B bicycle, you make $15 of profit. So the profit, I'm going to call that one Z, because your Z is usually used to calculate the money at the end. So Z is going to be $20 times A plus $15 times B. And that's not that this one is not this is not a line for us to graph. This is just an equation. So notice it doesn't say 20A plus 15B equals like a number. It just says equals Z. So the value of Z is what you're trying to find the maximum or the minimum of. So we want to find, do you want to find the maximum profit or the minimum profit? Maximum, right? So we need to find the maximum profit. So we don't know the maximum profit, so we can't actually solve the maximum profit first. We have to graph the other parts first. So let's go ahead and do that. So first of all, though, there's a couple of other requirements. You can't use a negative amount of bicycles. So how many of you go to college? You all go to college, right? How many of you wish you could buy a sports car? It costs a lot of money to buy a sports car, so you obviously can't buy one probably maybe you could, but most of you couldn't buy a sports car and go to college at the same time. How about this though? Could you buy a negative sports car? Then you could get, like if a sports car is $200,000, you could buy a negative sports car and then you would get $200,000 and then you could pay for college with that. Would you be able to go to the car dealership and say, hey, I want to buy one negative sports car, so just give me your money? Would that work? No, probably not. So you have to remember you can't make a negative amount of bicycles because you can't sell a negative bike. So A and B have to be positive or equal to 0. So let's add that in. So A has to be greater than 0 or equal to 0, and B has to be greater than or equal to 0. And that's going to that's going to be important because it completes the edges of the shape. So let's draw the shape now. Is it okay if I use desmos.com for this? How many of you have computers? So you could also use desmos.com, right? So if you have a computer, then I'm going to go ahead and show it to you on the computer. Although, tell you what, actually, if I use a computer, though, I'll have to delete this work. So I'm just going to use my whiteboard. I'm going to change my pencil to be the magical mode, so it goes straighter. So first of all, look at the equation that I just had. 5A plus 6B, and change that to an equal sign. If I change 5A plus 6B equals to 240, can anybody cover up the letter? Okay, pretend like the 6B is gone. So I'm going to cover that up in red. So tell me 5 times what equals 240? 5 times what number equals 240?
8.
8?
5 times 8. 40.
Wait.
Oh, okay.
5 times what equals 240? 240. 48. 48? Yeah, you're right. 48. Why does it keep changing? I'm going to stop using the magic pencil. Every time I use the magic pencil, it changes what I write. So 48. There we go. And what's the B? Now I'm going to erase that triangle that I drew. I mean the X, I'm sorry. Now I'm going to cross out the A. So the A-intercept is 48. The B-intercept is 6 times what equals 240? 40. 60. What? Which is it? 40? 40. Yeah, I think it's 40. It is 40. That's the B-intercept. Yep. So B equals 40. A equals 48. So now which one should I have be at like Y? Which one makes more sense to be Y? Should I have A be Y or should I have B be Y? What if I treat A like X and B like Y? Would that work? So let me pretend like A is X and B is Y. So let's do, well, let me do a fresh page for this so I have more space. Ready? So that's A instead of X, and that's B instead of Y. And I already forgot, what's the what was the B equal to, the B-intercept? 40? Okay, and what was the A-intercept? 48. Job. Better memory than me. Okay, perfect. There we go. So there's that line. And then what about the other line? Whoops, sorry, wrong button. Okay, let's go down to this line now. And if I cover up the B value in that line, tell me what 2 times what equals 114? 2 times what equals 114? 57. Now cover up the erase that X and cover up the A and ask yourselves 3 times what equals 114? 38. So B equals 38. Cool. So A equals 57, B equals 38. That's really random sounding, but let's work with that though. 57 and 38. So 50, wait, I forgot what to switch. A is 57 and B is 38. Wow, those are really random. And it has to be less than both lines, right? Okay, perfect. And it has to be bigger than 0, right? So it has to be bigger than A equals 0 and bigger than B equals 0 as well. So the part that you're going to shade is this little part right there. Presto. Sweet. So now we need to find the corners of that area. There's actually going to be 4 of them. So first corner is the easy one, 0, 0. Second corner is that corner right there, which is 30, no, not 38. 0 first, then 38. Then the third corner is that one. That's going to be 48 for X and 0 for Y. And then the fourth corner is, that's the mystery one. That one has no line beside it. So how do we find out where that fourth corner is? Any ideas? How do we figure out what the fourth corner is? Wow. Insane. Wow, this is difficult. So did you hear me say that this was difficult? So in order to find that corner, we actually have to look at the equations again. So where were the equations? Does anybody have those equations? Let me look back in my memory of my screen. 5a plus 6b equals 240. Let me write that down. 5a plus 6b equals 240. And then 2a plus 3b equals 114. 2A plus 3B 114. So any ideas how to find the point where those lines cross? Does anybody remember what it means when two lines cross? That means it's a solution to when you solve the system of equations, right? So sometimes, not always, but sometimes when you're solving these problems to find the maximum or the minimum, once in a while, the corner points will be where the lines cross, like that. And if that happens, then you need to solve those two equations which cross each other and find out where they cross. So let's go ahead and solve those equations and find out the values where they cross. So any ideas for how to solve this equation? What could I do? By -3. And then what? -2, okay. I'm gonna go with -2. The -3 could have worked just to take one extra step. So if I take the top equation as is, it'd stay the same. 5A plus 6B equals 240. If I take the bottom equation times -2, I get -4A minus 6B equals -228. And then what happens? Add them up. 5A plus -4A is just A. What happens to the 6B and the -6B? They eliminate each other, and then you get 240 minus 228 is 12, right? So I get A equals 12. And then how do I find B if I know A? Substitute it back in. So I'm going to pick the easiest one, which is probably the second one. I'll do that one. So I'll take the equation 2A plus 3B equals 114, and I'll put in 12. So 2 times 12 plus 3B equals 114. 24 plus 3B equals 114. Subtract 24. And you get 3B equals 90. Divide by 3, you get 30. So that point has a B value of 30 and an A value of 12. And we already decided to pretend like A is like X and B is like Y. So it's going to be 12 for X and 30 for Y. So 12 and 30. See if I can remember that. So that point right there is at 12, comma 30. And then how do I find out the maximum profit? How do I find out the maximum profit? Plug all 4 points into the profit equation, which was profit was equal to 20A plus 15B, right? 20A plus 15B. So profit is 20A plus 15B. So let me make a little chart. So if I take those 4 points and I plug them into 20A plus 15B, what is 20? What do you get if you do 20 times 0 plus 15 times 0? You get 0, right? So the value of that one is 0. By the way, if you make nothing, you'll make 0 profit probably, right? Like if we don't have a business at all, then you're making 0 profit. If you make 0 of bicycle A, you'd have 20 times 0 plus, and then you do 15 times 38. So what's 0 plus 15 times 38? 570? Is that right? Perfect. And then now what is 20 times 48 plus 15 times 0? Is that 960? And then what is 20? What's 20 times 12 plus 15 times 30? What do you say? 690. Perfect. I think that sounds right to me. Does anybody else get the same numbers? Perfect. So which of those scenarios would give you the highest profit level? That one, right? Now, by the way, this problem is a little bit of a simplistic problem because in this problem, both factors were in favor of one of the bicycles. Did you notice it actually took less? You got more profit from bicycle A, right? And you also got, it took less time to paint it, I think, as well. So bicycle A made more profit and it took less time to paint it and it also took less time to assemble it, right? So if everything is in favor of one thing, then it obviously makes the most sense to make only the bicycle. Oh, by the way, sorry, hold on just a second. If 48 is A, then what is B? 0, right? So if you're making 48 bicycles number A, you're making no bicycles of model B. And that makes sense because, like I said, bicycle A has the cheapest expenses and it has the most profit. So in that case, you'd make the most profit if you didn't do anything, if you didn't make any bicycles that were type B, if you only made model A. So you made 48 bicycles model A and 0 model B at all. So that would be that would make sense. But in most problems though, there's some factors in favor of one bicycle and there's other factors that are in favor of the other bicycle. And then it's usually not just going to be making one kind of bicycle alone. So let's go ahead and try one like that. Let's try number, I'll let you pick. Do you want to try number 14 or do you want to try number 15? Which one would be easier? Do you want to do one about students or do you want to do one about do you want to do one about 15 looks what? I think it's harder, okay. Positive awe. Okay, let's see if we can do 15. Maybe if we do 15 fast enough, we can also do 14 as well. Maybe. So I'm going to clear the screen so I can do 15 with Desmos.com the Great. Who wants to do it with Desmos.com the Great? Just so I can graph it more easily. So let's go ahead and clear this screen. And hold on just a second. Let's stop share. So I'm still going to be sharing my screen, of course, though, but so you can see it. Wrong one. Hold on. Sorry. Let me go. First, I have to go to Google. By the way, what does Google run with? Because Moodle runs with Noodle. Well, what does Google run with? Let's see. Desmos.com/calculator. Okay, I'm going to share the screen now. Ready? How do I do that? Click on share. Did you know that one thing that Zoom helps with is it helps people to be more kind because you always have to share things with it. All right, so here is my window. As I can into this. We're doing right. So number 15 shows you is the table on. So plane is $1,400 and is $500. Okay, sorry about that. The second equation says the payload is of the large plane. The large plane has a payload of 38,500 pounds, and the small plane has a payload of 5,500 pounds. So do you notice that the large plane can hold more cargo, but the small plane costs less money? So the cargo is in favor of the large plane, but the cost is in favor of the small plane. So in this case, it's a compromise. Some things are better, some things are better in some ways, and other things are better in other ways. So it's going to be a mystery to figure out how to do this. So that's the costs and that's the payload capacity. And you want to purchase some of these aircraft. So the thing is that hourly cost The hourly cost is limited to $28,000. Okay, and then the payload that you have to be able to fly needs to be at least 539,000 pounds. And you can only buy 15 planes. So the total planes has to be a maximum of 15. So look at all those different constraints. Let's try to make all of those constraints into equations. Are you ready for that? So what letter do you want to use for large planes? And what letter do you want to use for small planes?
L.
L and S. I like that. So L and S. So how could I express the hourly cost of the planes using L and S? That's $1,400 times L plus $500 about per hour times S, right? And what's the total maximum hourly cost that you can have? $28,000, right? So the total hourly cost, which is 14L plus 500S, has to be less than or equal to $28,000, right? Whoops, and I just realized Desmos.com doesn't graph them unless I use X and Y. So which one should I use for, should I use X for, which one should I use X for, and which one should I use Y for? Okay, so let's do X for large and Y for small. Does everybody agree with that? What happened? Uh-oh. Uh-oh. What happened? Okay, hold on. Huh.
It's just because the numbers are so big.
Oh, you think so? Well, it shouldn't be too big. Well, let me go on to the next one. What's the equation in terms of the total maximum planes? So if X represents small planes and Y represents big planes, then X plus Y has to be a maximum of 15, so less than or equal to 15. Oh, I see, it's shading them. Oh, okay. Oh, I see. Okay, so it was shading them like that. Okay, so wasn't sure what the red one was even doing. So yeah, there we go. Okay, so the black line represents X plus Y is less than or equal to 15. The red line represents 1400 X plus 500 Y is less than or equal to 28,000. Does everybody see that? And I'm fine with it if you want to graph this thing on Desmos.com, because you're still being your own free agent and doing it yourself. Not just like looking the answers up. Then what's next after that equation? Okay, how could we put the equation in about the payload? So the payload of the large planes, which is X, is 38,500. So wait, no, wait. Yeah, large was X, right? Okay, so 38,500 for X plus 5,500 for Y. And how much payload did you have to have at least? Greater than or equal to how much? 539,000, right? So there's that. So have we graphed all the information on the graph yet or not? Let me zoom in a little bit for you, by the way, because it might be a little hard for you to see it. There we go. Is that better? Perfect. So it says that we have the costs, and we graph the costs right there. So there's the costs, and here's the maximum cost. So we put all that information into this equation. Then there's the payload. There's a payload that we have, and there's a payload that we need. We have the payload that we have and the payload that we need in that equation. And then there's the total number of planes that we can have, and we have that in that equation. So there's the graph of all the information that we have. Now let's zoom in on it and find the corners of it. Oh yeah,
The last equation, you put the X plus Y is greater than.
Oh, yeah. Well, I think because it says that it needs to be at least 539,000. So I think that's correct. Because at least means it has to be equal to or more than. So let's zoom in and find what part of this graph is shaded by all the lines. Okay, it's hard to see, but there's one little area down there. See that part? That's that little triangle. That's the part that's shaded by all the lines. Because this little part is shaded by the gray area. And it's shaded by the red area. And it's also shaded by the light red area as well. Do you see that? So that little triangle way down there, that's the area that's shaded underneath or shaded in the which way the arrows point for all three inequalities. So do you agree that this is the triangle that we're looking for? Okay, perfect. I sure hope so. Let me read through the problem again, make sure I'm typing it in right. So it says 1400x, 500y is less than 28,000. And then it says 38,500x plus 550y is greater than 539,000. And then, oh, actually, no, I'm sorry, my fault. There's one equation that's wrong. But it was not because I did the math wrong, it's because I read the problem wrong. Doesn't it say in your question, it says that only 15 large planes were available? So it doesn't say anything about the small planes, it just says 15 large planes were available. So actually, it only says the large planes had a limit of 15, but there's no limit to the small planes. So what should I change?
Total.
So I need to change, says total large planes has a max of 15. Which letter represented large planes? X. So I need to take out the Y, and it's just the X only that can be a maximum of 15. There we go. Okay, now let me zoom in on that. Okay, so now which part of the graph is covered by all three lines? It's now this part, right? So do you see how that now there is this strange little triangle right here? This triangle right there is covered by all three parts. And can I go below 0 or not? No, because you can't have negative planes. So actually, it needs to be this corner, this corner, this corner, and that corner. So there's still 4 corners of it. So let's try to find the 4 corners of the graph. So what's this corner right there? What's that? That's 15 and 14, right? So the first corner that we're going to do is, by the way, I'm just going to erase, I'm going to click X on that because I don't need that information anymore because I've already got it into an equation. So now I'm going to plot the point. What was that point? I forgot. 15 and 14, right? So I'm going to put a point at 15, 14. So there's a little dot right there. And then let's find the next dot. What is that dot at? That point is at 10 and 28. This is why I like Desmos.com because it'll tell you the answers when you move your hand over it. So 10, 28, that's that one. So hold on, let me. So 15, 14, and then 10, 28. So that one's a green dot. And then the last 2 dots down there, they are at 15, 0. And this dot is at 14, 0. So those are the 4 corners of it. So do you see that strange looking shape? So first of all, any questions about any of that information? This was definitely what I think it was the hardest problem actually. So smart choice. So we have let's review real quick. What does this equation represent that says X is less than or equal to 15? That means the large planes, you can have no more than 15 large planes. What does this third equation represent? What does that represent? That means the payload of the large planes plus the payload of the small planes has to be at least 539,000 pounds, right? What does this top equation represent? The cost of the large planes plus the cost of the small planes has to be less than or equal to $28,000 per hour, right? So there's an hourly cost there's a limitation on how many large planes you can fly, and then there's the cargo capacity. Once you graph all three shapes, it makes a triangle like this. Then you find the four corners that are contained within all the graphs, which are those four corners. Now we're going to test out the function with those four corners, and I'm going to show you something incredible. You want to have something that's going to actually totally amaze you? Yes. Watch this. You can actually, oh, whoops. Oh no. How do you undo? There we go. Okay, sorry. I did not mean to do that. So let me zoom out just a tiny bit. I need to add in one more equation. How do I add another equation? Okay, click on the thing that says plus, tap and click on the first one that says expression. So let's type an expression. Let's use the letter F though. F parentheses of x comma y equals. Now there's a reason I'm saying x comma y. When you type f of x y into desmos.com, it lets you put in the whole formula for the profit. So the oh, actually, so it says how many kind of aircraft should the company purchase to have the maximum aircraft? So how do you calculate how many aircraft you have? Well, aircraft is just the number of big planes plus the number of small planes, right? So put that function in, and then guess what? All you have to do is just put the letter F in front of each of those. So if you put the letter F in front of the first point, it'll say 29. Put the letter F in front of that one, it'll say 38. Put the letter F in front of that one, it'll say 15. Put the letter F in front of that one, it'll say 14. So it's calculating the number of aircraft for each of those points. Now, which of those points has the most aircraft? That one does. 38, right? So let me zoom in a little bit so it's easier to see. So if you type in the function you want to calculate, like x plus y, and you put the letter F in front of the points, it will actually, but you have to have f, x, comma, y, just like that. If you leave out the x or the y on the left side, it won't work. So the most aircraft happens when you have the point 10, 28. So that means that you need to have 10 large planes and 28 small planes. Perfect. Okay, well, do you want to see if we can work through question 14 in the last 7 minutes? What's the same process? Let's try it. We can always restart it again on Wednesday if we need to. So let's go ahead and try it. That one is a little bit hard to understand because it was our first time using desmos.com. Okay, so in question 14, it says admission is $12 for adults and admission is $6 for students. So is that pretty clear? The cost costs you $12 for adults, $6 for students. And it says the proceeds are going to go to the, they're going to be donated. So they want to raise the most donations, right? So how do I translate the donations from the ticket prices into a function that calculates the total donations? So what if I said the total donations is called f of x and y, and there'd be 12 times the number of adults, like 12x, plus 6 times the number of y, which is like the students. Would that work? So that's my function for that. So I've translated the prices into like the total donations. That's the first step. However, though, the theater can only hold 210 people. So the theater can only can fit 210 people. How do I change that into an equation? Well, it'd have to be the number of adults plus the number of students has to be less than or equal to 210, right? Does that make sense? So then the next information it says is there must be at least one student to go with every 2 adults, right? So that's a confusing one. So there must be at least one student for every 2 adults. That's extremely confusing. So how do you put that into a math equation? So let's think about of a ratio. If at least there's one student for every 2 adults, then how many of the people have to be students? If there's one student and at least 2 adults, how many people is that total? 3. So that means there has to be at least 1/3 students, right? So the number of students has to be at least 1/3. So if the number of students, which is Y, right? The number of students has to be at least 1/3 of the total, right? And what's the total number of people? X plus Y, right? So the number of students is Y. That has to be at least 1/3 of the total amount. Does that make sense? So any questions about how I got that equation? So now let's look at the graph and see if we can find the borders of it. And remember, you can't have less than 0. So which part of the graph is shaded by the green line and the red line? Which one is shaded by the green line and the red line? And it's also bigger than 0. How about this triangle right here? So this triangle right there from this point at the top, that point at the top is 0, 2, 10. So let me plot that one. So 0, 2, 10. And then the point at the bottom is going to be 0, 0. And then the point on the right side is going to be, what is that? 140 and 70. 140 and 70. So we found the 3 corner points of that region. How do I find the most donations possible? How do I find the most donations possible? Well, remember the equation that represents donations has already been entered. It says f of x and y equals 12x plus 6y. Who remembers how to calculate the value of that function from a point? If you already have the point typed in. In Desmos.com, what do? Put an f in front of it. So if you put that point 0, 2, 10 into that function, it's 1260. Let's put 0, 0 into that function, it's 0. And if you put the other one into it, it's 2100. So which of those is the most donations? Well, so if you have 0 adults, and 210 students, the donations is $1,260. If you have 0 adults and 0 students, you'd have $0 of donations. You have 140 adults and 70 students, you'd have $2,100 of donations. So which is the most? Right, so the most donations you can get is $2,100. And to get the maximum amount of money, you need to have how many adults? 140. And how many students do you need to have? 70, right? So that's the last question from chapter 4. Are there any questions about that? So do you think it's exciting to solve these strange problems and figure out like how to get the most? So good job, everybody. That's actually as far as we're going to go into that topic. But that is an important topic though, because that's how computers make decisions to like decide what to do, like which way the UPS truck should go and things like that, to try to save the most amount of money. So good luck, everybody. And I think is the homework due on Wednesday night, or when does it due? I forgot.
Thursday.
Thursday, okay. It's going to stay that way, and then, but we can on Wednesday we can work a tiny bit ahead on into chapter 5 a little bit. So good luck, everybody. By the way, did anybody show up after I did attendance already or not? If anybody came after I did attendance, just let me know so I can put you on the attendance page.
Thank you, guys.
You're welcome. Thank you.